tree diagrams. These are really helpful when there's a sequence of events and we want to find their probabilities. And let's do this by an example. So here's the problem. There's 6 balls in an urn. Now an urn is just another name for a box. And as soon as I see something like that, I'm going to draw it. So here is an urn. I'll do it up here. Here's an urn, just a big box. And what I've got is 6 balls in here. They're identical except for color. Now 2 of them are red, 3 are blue, 1 is yellow. All right, so what have we got? We've got 2 reds, 3 are blue. That blue doesn't show up very well. And 1 is yellow. Here's the experiment. We're going to draw a ball from the urn, note its color, set it aside, then draw another ball and note its color. All right, so what we're going to do is we're going to reach in here, take a ball out, leave it, and then reach in and grab another one. So we're going to make a tree diagram to show all possible outcomes of this experiment and label the probability associated with each stage. So here's where we start. These trees are going to start and they're going to they're going to go horizontally, at least the way I do them. All right, so the first thing to do is reach in and grab a ball. Now, what could happen? How many possibilities are there? Well, we could get a red, a blue, or a yellow. All right, so I'm going to draw a branch for each one, a red, a blue, or a yellow. All right, so we could get a red, a blue, or a yellow. Now, what's the probability of getting a red? Well, we've got what? We've got 2 reds out of 1, 2, 3, 4, 5, 6. All right, so this is going to be 2/6. What's the probability of a blue? There's 3 blues out of 6. And a yellow, there is 1 out of 6. Now, if you add these up, 2, 5, 1 is 6. Right, something's got to happen, 6/6. We're guaranteed something's going to happen. Now, let's go to the second draw. So suppose we got a red. We're up here on this branch. Suppose we got a red on the first draw. Now, what could happen on the second draw? Well, we could still get a red, a blue, or a yellow. So let's draw branches for those. Red, blue, or yellow. A red, blue, or yellow. Now, what are these probabilities? Well, look, we got a red and we took the red out, right? So it's like over here, we got a red and we took it out. So how many reds are left? Just 1, and only 5 balls are left, right? Because we did this without replacement. So there's 1 out of 5. There's still 3 blues, but there's only 5 balls, so 3 out of 5. And there's 1 yellow out of 5. And sure enough, 1, 3, and 1 add up to 5, 5 out of 5. All right, but suppose we did this. Suppose we got a blue on the first one. Now we reach in and we grab another one. So what's possible? We could still get a red, a blue, or a yellow, right? We could get a red, a blue, or a yellow. And what are these probabilities? Well, if we got a blue on the first, right, you get a blue on the first and you take it out. So there's only 2 balls left, 2 blue ones left out of 5, right? Because it started 6, we took 1 out. So there's going to be 2, no, what are we dealing with? Reds. How many reds? Yeah, there's 2 reds out of 5. Now there's only 2 blues out of 5, and there's 1 yellow out of 5, right? We got a blue on the first, we took that out. So what's the probability of getting a red? Well, there's still 2 reds in there and 5 balls left because we took 1 out. All right, now, down at the bottom here, what if we got a yellow on the first? So what's possible? Well, if we got a yellow, we take that yellow and we put it out. So there's 5 balls left and no yellows. So what could happen? You could get a red, you can get a blue, all right? There's no yellows. All right, so actually I'm going to list it here. What are the probabilities of getting a red? Well, there's only 5 balls left because we took 1 out. 2 of them are red, so 2 out of 5. What about a blue? All 3 blues are left. And what about yellows? 0. There's no yellows out of 5. Okay, so that's what they're asking us to do here in Part A, is just to make a tree that shows all the possible outcomes of the experiment, and we've labeled the probabilities associated with each stage on the appropriate branch. Now I'm going to push it a little bit further. What is the probability of getting a red on the first and a red on the second? All right, so I'm going to write what I'm doing here. What is, save a little bit of room here. What's the probability of a red on the first and a red on the second? Well, I can follow it directly right here. What do I get? I have to get a red on the first and a red on the second. So and is a multiplication. So how about 2/6 times 1/5? So this is 2/6 times 1/5, and what I get is 2/30. Now, what is the probability of a red on the first and a blue on the second? Well, a red on the first is 2 out of 6. A blue on the second is this branch here, right? 3 out of 5. So this is going to be 2/6 times 3 out of 5. So I end up with 6 out of 30. Now what you might want to do is when you create this diagram is right next to each possibility, just write those. So what we're going to get is 2/6 times 1/5, 2/30. Right here, I'll get 2/6 times 3/5, 6/30. Now what is this one here? This would be a red on the first and a yellow on the second. So that's going to be 2/6 times 1/5. So that's going to be 2 out of 30. Now I'm going to do the rest of them, but I'm just going to put them in here and then come right back. All right, so I just filled them all in here. So for example, what would this one here be? How do I get here? Well, to get here, I have to have, come over here. I got to get a blue on the first and a yellow on the second. So a blue on the first is 3/6, a yellow on the second is 1/5. So what's the probability, and let's write it here, what's the probability of a blue on the first and a yellow on the second? Well, that's just going to be, follow the trail here, 3/6 times 1/5. So it's going to be 3/6 times 1/5, or 3 out of 30. Now what about this one here? What about getting, what's the probability of 2 of the same color? All right, so how can you get 2 of the same color? Well, here's what could happen, right? So I'm going to break this down like this. Here's what could happen. I could get a red on the first and a red on the second, or I could get a blue on the first and a blue on the second, or I could get, actually this isn't going to work, is it, right? A yellow on the first and a yellow on the second, but that's going to be 0, but I've listed all of them. Now, it's an or, right? You see those? Those are ors. And in ors, we know what to do, right? In ors, we're going to add. So I'm going to add these together. So it's going to be the, let me get this all the same color here. This is going to be the probability of a red on the first and a red on the second, plus the probability of a blue on the first and a blue on the second, plus the probability of a yellow on the first and a yellow on the second. Now, a red on the first and a red on the second. We've got everything listed. Here it is right here. Red on the first, red on the second. 2 out of 30, all right? 2 out of 30. Plus 2 blues, a blue on the first, and a blue on the second. That's 3/6 times 2/5. 3/6 times 2/5. Well, let me just do that. We just did it, right? So 3/6 times 2/5 is 6 out of 30. Plus now a yellow on the first and a yellow on the second. Yellow on the first, yellow on the second is 0. So we're just adding a 0 here. So what do we get? We get 9 out of 30. Now maybe we didn't need to write all this. I like writing all of it because it explains exactly where we are and what we're doing. But if I want the same color, where are the same colors? The same colors are where? Red and red, blue and blue, yellow and yellow. So I can just get this one, this one, this one. I can see it without writing all that down. Now let's try this one. What's the probability of getting, say, a red on the first and a blue on the second, or a yellow on the first and a red on the second? So I'm seeing an OR here, right? And in ORs, we know what to do. We're going to add. But now instead of writing this all out, I'm just going to look at my diagram and see what I've got. I want a red on the first and a blue on the second. Follow it over. Here's a red on the first and a blue on the second. That's 6 over 30, right? So this is going to be 6 over 30 plus, now a yellow on the first, and a red on the second. All right, follow it over. Yellow on the first, red on the second. That was 2 out of 30. So we're going to get 8 out of 30. So you can see how convenient these tree diagrams are when you're trying to get some pretty decent probabilities here.